Math 2, Unit 8, Final Review. I'm going to pick a couple problems. We're going to do several of them. I'm going to go somewhat faster than I normally do because it is review. If you need more, don't forget, you can go back to the videos that we have from previous sections. So, first few things that you're supposed to know. You can never leave your answer with any negative exponents. That means if you have a negative exponent, it's going to need to move to the opposite place. What I'm going to do is I'm going to just simplify these fractions using my rules of exponents. So if I was looking at Part B's question, I would have to deal with the exponent outside of parentheses first. That's my first thing to do. When you have a 3 outside of the parentheses, what that tells you is that you have 3 factors of this group of negative 2ab to the negative 2 times another negative 2ab to the negative 2 times another negative 2ab to the negative 2. You can kind of think of it like there's 3 of these factors, there's 3 of those factors, and there are 3 of these factors. 3 factors of each, meaning they're going to multiply each other every single time. So when I do a negative 2 times a negative 2 times a negative 2, that's a negative 8. I'm going to put that in parentheses. That's an a to the third. And if I have b to the negative 2 times another b to the negative 2 times another b to the negative 2, it comes out to b to the negative 6. So I do all that first. This blue parentheses becomes this, bless you. And what I can do after that is then I can just multiply everything. When I say multiply everything, that means numbers with numbers, A's with A's, and B's with B's, and then I'll deal with negative exponents. So technically there's an invisible 1 right here because I have one of these groups, and I have an invisible 1. I have a 1 times a negative 8 times a 1. I know that is a negative 8 for my number, my coefficient. For my A's, I have 3 factors of A, multiplying 3 more factors of A, and there's no other A's anywhere. So how many factors? I have 6 of them. Technically, we're adding exponents. For the B's, I have b to the negative 7. I have negative 7 of those factors, and then I have negative 6 of those factors, and this b right here has an invisible 1. Negative 7 and negative 6 makes negative 13, plus 1 is negative 12. So I've put everything together. The only thing I have not done is I have not dealt with negative exponents. This is not a negative exponent. This is a negative 8. That nothing happens with that. The only thing that I have to do something with is this b to the negative 12. This 12 becomes a positive when it moves from the numerator to the denominator or vice versa. So my final answer for 1b is negative 8, a to the 6th. That doesn't change. That's in our numerator over b to the positive 12. This becomes a positive exponent when it goes to the denominator. That means this stays in the numerator. That goes down. That's where I get my final answer from. You can see that. So let me slide it over a little bit. When you're multiplying things, you can add exponents. When there's exponents outside of parentheses, you can multiply them, and then division is subtraction, and then of course negative exponents move to the opposite place. So that is a review of number 1. Other things that you're going to have to remember how to do. You're going to have to deal with fractional exponents. Very similar to what you see here. If I look at these fractional exponents, 6 to the 1/10 and 6 to the 5th root of 6 to the 3rd. You're supposed to remember that this can be written as a base of 6. This is your exponent, and this is your root. Roots grows on trees on the bottom, so I'm going to put the root on bottom, and the exponent is a power. It goes, you get your power from the sun. The sun's up above. So I'm going to call this 6 to the 3/5 power times 6 to the 1/10 power. 6 to the 1/10 times 6 to the 3/5 Well, if they have the same base, what we can do is we can add their exponents. I can add 3/5 power plus the 1/10, but they have to have a common denominator when you do that. So I times by 2, and I have 1/10 plus 6/10. One-tenth plus 6/10 is 6 to the 7/10, and the directions specifically state give your answer in a form that has a base to a fractional exponent. So that is in the same form. That's what we want it to be. My answer for 2B is 6 to the 7/10 power. I'm going to go to 3B next. I'm not doing every problem. I'm just doing around so you guys can review and see what you remember and see what you need to review. If you have 27 and it says take the third root of 27 squared, you can do either the root first or the square first. If I know that 27 is 3 times 9 and 3 times 3, and I know there's 3 factors there, that's what this means. How many factors do you need to break out? You need to have 3 of them. If I want to, I can do this first or this first. I'm going to make it smaller before I make it bigger. I have 3 of those factors. A 3 can pop out. That 2 still stays there. The third root of 27 is a 3. Now square it. 3 squared is 9. My final answer for 3B is 9. If you want to double check yourself on these questions, you can punch these in on your calculators. Calculators can do that. And there will be a calculator allowed on this final. There's a lot of questions that you can double check yourself by using the proper buttons on your calculators. I'm going to talk about number 4. There's questions like number 4 on your final. You're supposed to pick true or false. Are root 3, root 7, root 11, root 13, are they all real numbers? What's a real number? A real number is any number between negative infinity and positive infinity. These numbers are real. That is true. All the numbers are rational numbers. Rational numbers means that it can be written as a fraction, or it can be a repeating decimal, or a decimal that ends. Are these rational? If you were to type in root 3 on a calculator, you would not get a number that repeats itself. These are the absolute opposite of rational. They're actually called irrational numbers. So I'm going to put that it's false for B and it's true for C. They do not end, they do not repeat. They're irrational numbers. All the numbers are integers. Integers are whole numbers between negative and whole numbers, 0 or positive whole numbers. These are not whole numbers, they're decimals. That is definitely false for number 4 as well. So there's several other things that we're going to need to know how to do. We need to know how to add radicals, how to subtract radicals, how to do other problems. I felt like we did a lot of that stuff beforehand. There's going to be some of this stuff on your final for sure. Make sure you remember outsides multiply outsides. Here's what I mean, like the -5 and the 7 multiply each other. Insides multiply insides, but a lot of times when we did these problems, I did not multiply the 12 times the 3. I just put them both inside. The reason why I didn't multiply them is because I knew that they would have to break down anyways. if you break it down, you're looking for a square root. You're looking for a pair anyways. There's a pair of 2's. Put the 2 out there. Here's a pair of 3's. Put the 3 out there. 3 times 2 is 6. 6 times negative 35. And there's nothing left inside. I'm getting negative 210 for my final answer on 5B. And you can double check that on a calculator too, by the way. You'll also have to add them. You'll have to subtract them. You're going to have to divide them. I'm not going to go too much into that. But what I really like are these problems like 6A and 6B. Guaranteed to be on your final. They're trying to figure out, do you know your rules of exponents? So if I look at this one, 6A, this is 18 to the 3/4 power. The root goes on bottom. The exponent is the power. It goes on top. Times 18 to the 6/4 power. The power's on top. The root's on bottom. Equals 18 to the x over 4 power. So what we're doing is we're switching these from rational form into exponential form. And if they have the same base and they're multiplying, we can just add their exponents. 3/4 plus 6/4. They already have the same denominator, which would be 9/4. And this side is 18 to the x over 4. So if you look at this, 18s are the same, the 4s are the same, 9 and x have to be the same. X is going to have to be equal to 9 for 6A. I'll turn the paper over. I think some of the hardest questions on your final come whenever they use this keyword, all. Select all the expressions that are equivalent to this. That means that there's going to be more than one, most likely. Sometimes 2 answers, sometimes 3. So maybe even 4. We have to check every single possible choice that they have there to see if it's equivalent or if it's not. So the first thing I do is I go, well, what would this look like? For me, this is the third root, and this, since it's to the whole group of the third root of 8x squared squared. So when I look at choice A is equivalent. It's the same exact thing that I have written down. A lot of times I do the problem by itself before I even start. Then I try to figure out what else could I do with it. Well, if I have a squared, thank you. If I have a squared, that means that I'm going to do 8 times 8 and x squared times x squared. 8 times 8 is 64. X squared times x squared is x to the 4th. I'm doing that square here and the square here. I don't see anything else that looks like that. But what's funny is that I look at this and I say a 3 and a root 64 and an x to the 4. Here's an x to the 4th and here's a 3 and that's an 8. And I look at these two things and I say, well, those aren't the same. Everything else is the same except these aren't. It can't be B. It's impossible. It won't work. I look at this and I see a 3x to the 4th, 3x to the 4th inside, and there's a 4 outside. So that makes me go, what did they do? Did they break this down into 4 times 16 and 4 times 4? Because 4 to the 3rd power is 64. Maybe they factored out a 4 from here and have the third root of x to the 4th. Let me look at that. That would mean D is equivalent. If I look at this one, and I see the 3 and the 2, and the x to the 4, this matches, that matches, but the 64 and the 2 are not the same. It can't be e. So now I need to check this one. There's a 4 outside, there's a 4 outside. Third root, and this only has one x, and this has an x on the outside. Maybe they broke this down into x times x times x times x. There's 4 factors. Maybe they took out 3 of those and put the x right there, 4x times the third root, and only 1 left over. That's equivalent as well. I believe the hardest questions on your final will be the ones that have multiple correct answers. What you have to do is pay attention anytime it says the word all, select all that apply. 9 times out of 10, there's more than one right answer. Check everything. Double check and look for things that are going to put you on the right track. I'm going to jump down to number 12, and then I'm going to let you try the rest of these on your own. The only things that we kind of talked about rational, irrational, but this one was so tough for you back then. Number 2, 12, 2 is a rational integer. 7 is a rational number because it's a nice whole number, but root 2 is irrational, root 7 is irrational, 2 root 7 is irrational, and 2 minus root 7 is irrational because of that root 7. Choose 2 numbers that when you multiply them, it's irrational, and when you add these, it is rational. We're going to multiply them, it's irrational, and we add them, it is rational. If I'm adding 2 numbers and it's rational, 2 times 7 adds to be a rational number, but it doesn't work when you multiply them, so I can't use those numbers. I want to add 2 numbers that are rational. What if I added this one and this one? What if I added root 7 and 2 minus root 7? Let's see what that would look like. Root 7 plus 2 minus root 7. This and this, a positive root 7 and a negative root 7 would make 0. If I were to add these together, I would get the number 2. If I were to multiply them, though, I would get 2 root 7 minus 7, which would be irrational. So I think that satisfies part A. I want to multiply them, it's rational. And when you add the same 2 numbers, it is irrational when I add them. So let's see. What about root 7 and 2 root 7? Why would I choose these 2 numbers? If I multiply them, if I multiply a root 7 times 2 root 7, you would have a pair of 7s and the 7 would pop out and it would become rational. When you add the same 2 numbers, it's irrational. 1 root 7 plus 2 root 7 would have a sum of 3 root 7, which makes it definitely irrational. If you multiply them, it's irrational. When you add the same 2 numbers, it's irrational. Let's keep this one. 2. There's answers vary on this one. If I multiply 2 times root 2, it becomes 2 root 2. It's irrational. If I add them, 2 plus root 2 is still 2 plus root 2. It's still irrational. I could have chosen any whole number, integer, and any radical, and it would have worked as well. So that's where I'm going to end your notes.